Welcome. In this video, we're going to use the alternating series test to determine whether this series converges or diverges. So the first thing I'm going to do is just give us a quick little rewrite. So this is the sum from 1 to infinity of negative 1 to the n minus 1 power times 1 over 3 plus 5n. Now, the only reason I did this rewrite, you don't even have to do this, is to just make it clear that this part here is separate from the alternating portion. And that's what we want to look at. So let b sub n equal 1 over 3 plus 5n. The first thing we need to do is ask ourselves, is b sub n decreasing? There are a couple ways to do this, and I'll show you two different ways. So let's not call it two. Let's call it method A and method B. So method A, I'm going to use a derivative. So let f of x equal 1 over 3 plus 5x, where x can be any real number. The only difference here is n is, integers and x is real numbers. So f prime of x is equal to negative 5 over 3 plus 5x quantity squared. If you don't see this, then please pause your video and evaluate this derivative. Let's ask ourselves, for x greater than or equal to 1, and really that's all we're concerned with, will this derivative be positive or negative? If the derivative is positive, then clearly we know that our function would be increasing since its tangent line would be positive. If the derivative is negative, then we know the function is decreasing since the tangent line would be negative or decreasing, have a negative slope. Well, no matter what value we put in here, and look at this, I forgot something really important, so I'm going to put it in red. There we are. I forgot that x, my bad. So no matter what value we put in for this x, this is going to be positive and has no impact on this negative here, so this will always be less than 0. That tells me that f of x is decreasing, so b sub n is certainly decreasing. Another way we can show this is we can look at the next term. And what I mean is b sub n plus 1, well, that's equal to 1 over 3 plus 5 n plus 1, which is 1 over 8 plus 5n. If you don't see how I got from here to here, please pause your video and work that out algebraically. So what just happened here? The denominator got bigger. So the denominator got bigger. That tells me that this value is now smaller. The unit fraction divided by this larger denominator is smaller. Thus, we certainly know that b sub n is decreasing. And there's probably other ways to show this, but these are the two that come up in my mind right now. So there you are. Choose what works for you. While mathematics delivers universal truths, it doesn't mean that we all have to take the same road to those truths. All right, so as you can see, I made this text smaller, and I'm going to write here, yes, it is decreasing. The next thing we're going to do is evaluate this limit. The limit as n approaches infinity of b sub n. So let's go ahead and do this. The limit as n approaches infinity of 1 over 3 plus 5n does equal 0. So we know that this entire series, not this one, not this one, but this entire series with the alternating sign of positive and negative converges. And then really quickly as an aside, if we take a look at this series, that is the absolute value of our original series, we end up with the sum from 1 to infinity of 1 over 3 plus 5n, and this will diverge by the integral test. which I'm not going to show in this video, but I bring that up to show that this series is not absolutely convergent, it is only conditionally convergent. Hopefully you have a fantastic rest of your day, folks.